All right, good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, just a quick one. We're going to go through Physics 1 1100 for this, the students at Chalimbana University in association with Mufurida College of Education. So now I'm going to start from question B here because question one is you can check them out by yourselves. So now question B here asks us to determine the physical quantities represented in the dimensions this. So basically they are asking us to identify what this is or what that is. Okay. So now on dimension analysis, you have to know what the letters represent. So for instance, M, capital M, this represents mass. So wherever you see capital M, that is mass. Wherever you see L, that is any length. Okay, length meters. Yeah, meters. So length in meters. So yeah, length in meters. Then where you see T, that is time. And a constant has one dimension, or one is equals to a constant has a dimension of one, then yeah, and current where you see I, that is current. Where you see I, that is current. Okay, so these are the symbols that you should know. Then now coming to this, how are you going to determine the physical quantities here? So you will say M is mass. So mass is measured in kgs. So we are dealing with the first one. So the first one we have M in mass. Mass is measured in kgs. Then L is length. So we say meters squared. So because L is squared, then times second to the negative 2. Okay. So this can be written as kg meters squared per second squared. So what is interesting here is that you can factor out squared here because squared. So we can factor out squared. It would be kg meters per second squared. Okay. So now meters per second is velocity. So velocity. So this is velocity squared. Kg, that is mass. So we say m. Then there is a 1 here. There is a 1 here in front here, so the dimension of that is a constant, so we can have a constant there. So this formula is the formula of kinetic energy. The constant is 1 over 2 mv squared. So this is a kinetic energy. So the first one here, this is kinetic. This is kinetic energy. Kinetic energy. Okay, so that is kinetic energy here. Yeah, so that is how you identify the physical quantities. So all this working should be shown right here. Then we go to the second one, which is mass. So the second one, we have mass, which is kg. Kg meters, then L is meters, then T is time, so that will be second to the negative 2, which is equals to kg meters per second squared. So meters per second squared, that is acceleration, and this is kg is mass, so this is ma. Okay, so that is ma. What has the formula ma? This is a force, so this is equal to a force. Okay, and you're done there. And now you're asked to work out the dimensions of the following. So they want you to write this in this form right here. Okay. So we need to use the formulas of each of these to write them in this form. So let me write it here. So we know that kinetic energy is equal to half mv squared. Okay. M being the mass, so mass m is equals to capital M. V, velocity is equal to meters per second, so which is equals to meters will be L, second will be T. Okay, looking at this, second is time, so that will be L over T. And now this is squared, so if we square both sides, so if we say V squared, we also square this side. So meaning that kinetic energy and the dimension of 1 is equals to 1. I mean the dimension of a constant is 1. So kinetic energy equals to the dimension of half is just 1 times m, which is our mass. So we say capital M. Then our V squared is L squared over T squared. So we can distribute the L and the T there. So we can finally write it here. We say kinetic energy is just, so 1 times everything there, that will be just 1. It will be capital M times L squared over T squared. Okay, or we can write it in linear as L times T to the negative 2. Okay, being T at the denominator there. So that will be the dimensions of kinetic energy. Now we look at density. Okay, so density, which is rho, is equals to mass over volume. It's equals to mass over volume. Mass is capital M. Volume is length times breadth times height, which is just, they're all length, so that would be length times length times length, which is length to the power 3. So putting everything there, our density is just equals to mass, which is capital M, over length to the power 3. So we can write it here. So this is equals to M times, we can write it on top as L to the negative 3 right there. Okay, so those are the dimensions of kinetic energy and density. Here we come to question D. Raise this. Question D says it is suggested that pressure at depth h in depth h of depth h in a liquid of density rho is this. So I'm sure there was a typing error. Should be pressure equals to rho gh. Okay, rho gh. But anyway, it could still be worked out, but we have not been told what C is. So we've just been told where G is the acceleration due to gravity, so that whether the dimensions is correct or not. So we don't know what C is. We've not been told what C is. Is it a constant or what? So I'm presuming the formula was, it suggested the pressure at depth height in a liquid of density rho is given by rho gh, where G is the acceleration due to gravity, and determine whether the formula is dimensionally correct. So we can let C to be 1, considering that it is a constant. So let C equals to 1, considering that it's a constant. So our rho equals to, our density, our pressure equals to rho GH. Okay. Rho is the density. We know the dimensions of the density, which is just m times L to the negative 3. But here you have to derive the process like we did here. After deriving, you get that. Then for gravity, this is basically equal to meters per second squared. It's acceleration actually. So this will have a dimension of L over T squared. Then height will just have a dimension of 1, and C is equals to 1. So here we're saying C is equals to 1. I mean pressure will be equals to C, which has 1. So we say 1 times rho density, which is equals to m times L to the negative 3 times G, which can be written as L times T to the negative 2, this here, and H, which is just L. No, I wrote H. H is length, so that will be L. So times L. Okay. Now, before we proceed, we have to define what pressure is. So we need to show that pressure equals to force over area. So that is the definition of pressure. Pressure is equals to force over area. Basically, force is mass times acceleration. Mass times acceleration. So we know what acceleration is. So that would be mass times acceleration. So mass times acceleration, which is L over T squared over area, which is L squared, like that. So that is what we need. So now, given pressure, which is equals to M, we can write this. This can simplify as L to the negative 2. So this will be L to the negative 2, because the powers of the same base, the bases are the same, so the powers will add. So negative 3 times plus 1 will just be negative 2 times T to the negative 2 times L. Okay, so now we know that this right here, which one right here? Okay, so we can rewrite this and this. We can write them as M times L to the negative 2 times, so this is L times T to the negative 2. Then we know that L times T to the negative 2 is equals to acceleration. Okay, then we know that capital M is equals to mass. Acceleration and mass. So this can be written as mass. The L can be down here, the L to the power 2. So when we bring it down, it just becomes positive 2 times this becomes acceleration. Okay, and L squared is equals to area. So this will be mass times acceleration over area, which is equals to force over area. Therefore, the statement is true. Okay, so statement is true. So maybe from the top, just a recap. So we first broke down the dimensions of row GH. So C will have a dimension of 1 because it's a constant, though we were not told whether it's a constant or not. Then we have row GH. So C will have a dimension of 1. Then row is given by this formula right here. We know that row is mass over volume. So mass, which is m, volume will be L to the negative 3. Then we have G is given by meters per second squared. So meters is L over T squared. Then H is length. So H will be equals to L. And C will be equal to 1. So replacing that there, we're going to have rho equals to m L negative 3, L negative, and so on and so forth. Then we need to show that rho, so we need to show that this simplifies to force over area. So which is basically m times L. So we started simplifying. So we need to show that this simplifies to force over area. So rho is equals to ml. We simplify here, we add these, we're going to have that. Then we identified that L times t to the negative 2 is acceleration. So we replace this with acceleration. Then m is mass, so we say mass. Then L squared is area, so which is this formula right here. Okay, so that proves formula. All right, on to question 3. Calculate the maximum possible area. The density of a metal cube, which is given by mass over volume, is calculated from the following data. So mass is equal to, that is 12.2 plus 0.1 for the maximum possible error, and for the minimum possible error, that is m is equals to 12.2 minus 0.1. Okay, so that is the maximum. So sum applies, so we can add 12.2 and 1. This will be 12.3 grams for the maximum possible error. And the cube's length, which is L, for the maximum possible error, will be adding 0.5 to that. So this would be 2.15 centimeters. Okay, so that is 2.1 plus 0 for the maximum, and for the minimum, this is equal to 2.1 minus 0.05, which you can calculate. So now what we're interested in is for the maximum part. So you're asked to find the volume. So using this formula here, are we able to find the volume, or we're going to use this right here to find the volume? So volume equals to L to the power 3 for a cube. Okay, so volume is equals to L to the power 3. In this case, it would be 2.15 to the power 3, which is, let me just pull out my calculator here. 2.15 to the power 3 would be 9.938 centimeters cubed. 9.375 centimeters cubed, which is approximately um, 10 centimeters cubed. We can round off to the, okay, let's not round off because all right, we can say this is 9.94 centimeters cubed. Okay, so that is our volume. So density is equals to mass over volume. So we have the maximum error on the mass that we can make, which is 12.3. So that will be 12.3 all over the volume, which is what we have here. 9. Let's use the now the not the non-rounded off 9,938,375. Okay, so that will be 12 divided by, so this will give us 1.207440854. Let me just recheck that. That will be 12.3 divided by 9.938375. Okay, it's actually 93. Okay, supposed to be 1.237 237626876, which can be approximated to 1.24. Then the units will be grams per centimeter cubed. Okay, so that will be your density. Okay, then components of the particle velocity in 3 dimensions at right angle that respectively determine the actual velocity in practical. So this is a planar forces. So what we do here is we need to find the resultant velocity, and basically we have to resolve the velocities in components. So we need to resolve the velocities in the components. So let's consider an x or y plane. Consider an x or y plane. Okay, let's consider an x or y plane like that. Then we know that components particle has 3 directions at right angles. At 3, so this is the right angle. 12 it right angle. Let me just read through the question properly.